Okay, let's look at another example. I'm actually not sure why. I'm actually not sure why I decided to stop recording because I can just do this all in one video. Anyway, I'm going to take you through a few more examples. As we go through these, I want you to pause the video, try them out for yourself, okay? Before I show you my solution. So we want to do x plus 2 times x minus 3. I'm not even going to use my tiles. Okay, I'm just going to draw the solution, if that's okay with you. So let's do x plus 2 times x minus 3. Oh, maybe I want to use my tiles here. Yeah, maybe I'll use my tiles still for them. X plus 2. X plus 2 and x minus 3. So almost the same problem as before. The first example we did together was x plus 2 times x plus 3. If we wanted to do x plus 2 times x minus 3, we would represent that this way, right? Oh, my fingers are too sticky to get the tiles to stay where I want them. Okay. So x plus 2 times x minus 3, right? So I'm using red tiles to represent the negative unit, right? X plus 2 times minus 3. Same trick as before, okay? These lines have to extend all the way through. Now, the only thing that's tricky about this is that you have to sort of establish the rule, I guess, that if you have the same colored tile, then the result is gonna be blue, right? So a blue times a blue is a blue, a red times a red is a blue. If you have different colored tiles, then the result is gonna be a red tile, right? So a blue times a red times a blue is also a red. Okay, so same color, blue tile. Different colors, red tile. Okay, so here I have an x times an x, and they're both blue. The only tile that'll fit in there is an x squared tile. Here I've got an x times a 1, both blue tiles, and the only tile that will fit in there is an x. Same thing goes for that one. Here I've got an x times a unit. The only tile that'll fit in here is an x tile, but because I have a different colors, right, blue and red, the result has to be red. Okay, and same thing goes for this one and for this one. And then finally in these spaces, of course, I'm going to have unit tiles. All we have to do is determine the color. Okay, so they're going to be unit tiles, and I have a blue times a red. Different colors means that I need red tiles. Okay, so I get something kind of like that at the end of the day. Now, when we write down our answer to this, remember that 0 pairs still cancel here. Okay, so since the 0 pairs are still going to cancel, this would be how I would express my answer. But since 0 pairs cancel, for the purpose of visualizing it, I'm going to say, okay, these two will cancel each other. These two will cancel each other. And so my answer must be x squared minus x minus 6. Okay. And once again, that's something that we can verify, right? That's something that we can verify by actually foiling it, right? X plus 2 times x minus 3 is x squared minus 3x plus 2x minus 6. Now combine your like terms in the middle, and sure enough, right, we get the appropriate result, or we get a matching result to what we did before anyway. So what else did I want to say? So showing the, like if you're drawing out the solution, and actually I was really impressed. Some of you left the tiles on your homework page when you scanned your homework page to turn it in, and that was awesome. Because then you could just leave the tiles there and you didn't have to worry about drawing them, which is like pretty nice. But if you were drawing it, okay, I'm just gonna fill these in. This was my x minus 3. This was my x plus 2. I have x plus 2. I'm just going to put a plus sign for a positive one. And I guess I could have called these negatives up here. But anyway, this was an x squared tile. This was an x tile, an x tile. This was a negative x, a negative x, a negative x. And then these guys down here were all negatives. So if this were a test or something, you could say something like, well, this tile and that tile will cancel, this tile and that tile will cancel, and so my result is going to be x squared minus x minus 6, right? Okay, so that's that one. Let's do another example. Okay, sorry, bear with me. Okay, another example. All right, let's do 2x plus 1 times x plus 3. Okay, so I'll give you a second to work that one out. I'm not going to use tiles this time. Except maybe to get the right spacing. So I'm going to do 2x plus 1 down the side. So there's 2x plus 1. And then I'm going to do x plus 3 along the top. Can you guys hear my kids? X plus 3. Okay. Okay, and once you've done that, once you've filled out your grid, you've got your answer, right? This is an x squared tile. This is an x squared tile. These are all x tiles. And then these are all positive ones. I guess I could call them plus signs for positive one. Okay, you count that up, you've got 2x squared, 7x, right? 6x is here and one more down here makes 7x. and 3, right? So 2x squared plus 7x plus 3. I'll leave it as an exercise to you to verify that by foiling. Okay, so I'll let you FOIL that out if you want. Let's do another one. Let me give you kind of a slightly more challenging one maybe. We'll throw some y's into the mix. Because I think you've got the idea. I think you've probably got the hang of it, but we'll see. So let me give you, so first of all, I'm going to make one of these a trinomial instead of a binomial. And for another thing, I'm going to throw some y's into the mix. Let's do 1 minus 2x. See, so you're going to see it's already getting crazy, right? 1 minus 2x times x plus 3y plus 2. Okay. So this is about as nasty as these things can get, right? Go ahead, pause the video, and see if you can work that one out. I may not have given myself enough room for this, but but we'll see. 1 minus 2x. You know, maybe I'll use a different writing system so I can like separate out what my answer is or whatever. Okay, so I'll use red ink for those lines. Okay, 1 minus 2x. Oh, good, it'll fit, just barely. Okay, so there's 1 minus 2x. X plus 3y plus 2. I have a feeling this is not going to fit on my page. Unless I make my tiles smaller. We'll see. There's x. See, because my y's are so long and I have to fit 3 of them on here, it's not going to work. Here's what I'm going to do. I'm going to grab another page so I can extend this out further. So how much have I done? I've done 1, 2, I need a third y. Got to extend all of these lines. Okay, so there was x plus 3y, and then here's plus 2. Okay. There we go. Okay, so now you can see the whole thing. Okay, so I've got x plus 3y. So y, and then 2. All right, so now all that's left is for you to figure out what these tiles are, right? And I didn't draw them perfectly, but that's pretty clearly an X tile right there, right? It's got to be an X tile. And it's a positive tile and a positive tile, so that's going to be a positive X. This one is pretty clearly a Y tile, right? That's what fits right there. It's got to be a Y tile. Again, positive and positive make a positive. Another Y tile, another Y tile. And this is pretty clearly a unit tile, right? Positive and positive. Okay, what's this tile? Well, it has a width x and a length x. So that's got to be x squared. Okay, so that's x squared. I don't know why on my screen it looks so rectangular, but that should be a square. So that's x squared. Oh, but it's a negative x. So that's a red tile and a blue tile. That makes a red tile, right? So negative x squared. And I suppose same thing's going to happen here, right? Negative x squared. Now what should go in here? What should go in here is a tile that has length x and width y. The xy tile is the one that does that trick, right? So it has length x and width y. This would be even better if you used a ruler, you know, because then everything would be perfectly, you know, spaced out. But that's an xy tile. Only I guess I should have been using a red one because it's a negative x and a positive y. So that's going to make a negative xy. And I suppose that means this one's also a negative xy. And this one's also a negative xy. And this one's also a negative xy. Right? They're all the same. They're all the same tile. All the same, you know, shape and size. So then all I have left to do is to figure out what these four things are. This tile should have a width of x, right? So it should have a width of x and a length of 1. That's going to be an x tile then, right? So an x tile goes there, 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 and there. Although they should all be negative because it's a negative x times a positive 1. Okay. Putting that all together, let's see. So I've got an x tile, but I'm going to cancel it with one of these negative x tiles, right? 0 pairs, cancel. I've got 3 y tiles. Do I have any negative y tiles that'll cancel them? I don't see any. So I think I'm going to have 3y. Oh, I guess I should have said. I should have counted my x's, right? I did count. I did cancel this positive x with this negative x, but I still have negative 3x left over, right? So I guess I should have said, all right, so I've got negative 3x. I've got 3y, they're positive. Okay, I've got a couple of negative x squared tiles. So I'm going to have negative 2x squared. And then I've got 6 of the negative xy tiles. So I'm going to say negative 6xy. And that does that. Wow, what would this look like if we multiplied it out algebraically? Let's see. I'm out of room, so I'm going to have to move my dot cam. But if I wanted to multiply this thing out algebraically, so let me do it in this space up here. 1 minus 2x times x plus 3y plus 2. Well, this isn't even foiling. This is just like you have to multiply all of these times all of these. So I'm going to do 1 times x. I'm going to do 1 times 3y. I'm going to do 1 times 2. Then I'm going to do negative 2x times x. Negative 2x times 3y. And negative 2x times 2. And if you're confused by that, well, you should probably review your algebra a little bit. But also don't feel too bad because it is kind of confusing, right? It's kind of confusing. Whereas I think the algebra tiles are so intuitive. This is something that it's like you have to learn all kinds of rules and stuff in order to be able to do it this way. But let's see now. So the only like terms I have are this positive x and this negative 4x, and that'll make a negative 3x. And then everything else comes along for the ride. So plus 3y plus 2. Oh, where did I miss my units? Oh, yes, in the diagram down here. I'm sorry. I missed these 2 units in my diagram when I was writing out my answer up here. So I should have a plus 2 in my answer. That's absolutely right. Some of you are probably screaming at the screen like, but you're missing the plus 2, or what happened to these units, right? You're right. They should have been in there. Anyway, negative 3x, 3y plus 2, and then a negative 2x squared and a negative 6xy, sure enough, right? Okay, so that's that one. I think I really will end the discussion about multiplication there.